While satellites have become crucial to our modern economy by delivering services such as mobile communications and television, it is the inspirational endeavour of exploration that will enable humans to improve our understanding of the universe and take the next step in the evolution of our species. Human exploration of space has always been at the forefront of space science and engineering, but to take the next giant leap will require advancements in the field of robotics and autonomy. But Mars, like the Moon, is a big place and will require a number of different rovers and robots to explore it thoroughly. And that's where the Space Robotics Strategic Research Cluster, or SRC for short, comes in. The Space Robotics SRC is developing a suite of common, standardized capabilities or building blocks that will efficiently produce an array of different rovers that can be deployed in a variety of exploration scenarios. But current rovers can only travel a few tens of meters per sol because most sites of scientific interest are some way from the landing site and, because they're unable to evaluate the risks around them, they must wait for plans and commands from Earth, which takes a long time. By improving a rover's decision-making capability, we can create robots that don't necessarily have to rely on frequent planning from Earth. They can make their own decisions. Whereas a mission that would cover a kilometre of distance took days or even weeks, rovers with this kind of capability will be able to cover the same ground in just one day. What's more, last generation rovers were limited to predetermined paths, meaning that they could miss interesting sites. To maximise the scientific returns from future exploration missions, intelligent rovers will be able to identify points of interest by themselves, then deviate from predetermined paths to undertake new scientific investigations of areas or objects that controllers on Earth might miss. Also, current rovers aren't able to explore certain areas such as cliffs or craters for science, or even surveying lava tubes for habitability. It's just too difficult. But by using specialised rovers that can cooperate, think and act in groups, they can work together to figure out how to enter these tricky areas and then explore them. Exploration of difficult areas is not the only scenario in which cooperative robots are needed. If we eventually want to build the basic infrastructure needed to establish bases on the Moon and Mars, such as landing pads, storage space and habitation modules, cooperative robots will have to complete construction tasks using the resources they have to hand in the mission environment. Once that is in place, these little robots will have helped us to take those tentative but crucial next steps into improving our understanding of the universe, our origins, and ultimately, our destiny. The ambition of the SRC is to lay the groundwork for such missions, and to put the European space sector at the forefront of space exploration.